When we're studying chemical equilibrium, one of the things we need to understand is that when a system reaches equilibrium, it is about rates. So it means that the forward reaction is happening at the same rate as the reverse reaction. But what's also important to understand about this is that the concentrations of products and reactants are not necessarily equal. You see, to talk about this, let's take a look at an example. So I just have a made up chemical equation. So substance A is going to react with substance B, and that's in equilibrium with substance C and substance D. And then the coefficients I've written in blue and underlined for you and used lowercase letters so that we can tell them apart from the actual substance. This is just a fake chemical equation as a stand-in for a real one. So what this really means is that A and B are reacting and turning into C and D. But at the exact same rate, C and D are turning back into A and B. Remember, when they're happening at the exact same rate, it's kind of like being on that treadmill. Visually, it looks like nothing's happening, but the reaction is actually having constant back and forth in order to stay at equilibrium. But what's important to understand is you can have, let's say, way more of this than you did of this. Or you can have way more of products than you do of reactants. They don't necessarily have to be equal. And to help us understand the amounts that we're dealing with at equilibrium, we use something that is called the KEQ. You see, K in chemistry represents constant, and EQ means equilibrium, so we're talking about the constant of equilibrium. When we set up an equilibrium constant, or a KEQ, we always do it by taking the concentration of the products and then dividing those by the concentration of reactants. No matter what the chemical equation, no matter what the equilibrium system, we always take products divided by reactants. So what I wanted to do is show you how we would actually set one up for this equation right here. What we would do is take the KEQ, and then we would take our products. So that's substance C. So we would find the concentration of substance C, and it has to be the concentration at equilibrium. And then we're actually going to raise it to the power of its coefficient. So whatever its coefficient is now becomes an exponent for that substance. And then we're going to multiply that by the other products, which in this case is substance D. And substance D is also going to be raised to the power of its coefficient. So those are our two products in this chemical reaction. Those are going to be multiplied together, raised to the power of their coefficients, and then we're going to divide that value. We're going to divide it by the reactants. So we're going to do the same thing. We're going to take our reactants, substance A, and raise it to the power of its coefficient, which is A. Then we're going to take substance B and raise it to the power of its coefficient, which is B. This would be the equilibrium constant for this chemical reaction. Products divided by reactants, always raised to the power of their coefficients. So now that we've seen a really general version of it, let's take a look at an example where we're actually using a real chemical equation. So here I have two separate chemical equations, and we're going to actually write these out into their equilibrium constants. So we're going to take our first equation, H2 as a gas reacting with I2 as a gas to produce 2HI as a gas, and this system is in equilibrium. So the KEQ for this equation would be our concentration of products. That's going to be HI, and we raise it to the power of its coefficient. So it's going to be squared. Now that's going to be divided by our reactants. And remember, when we have more than one reactant, we multiply their concentrations together. The other thing is the coefficient here is actually just a 1. When we don't write any number in front, basically what we're saying is there is one of those. And so we would have a coefficient of 1 here, but anything raised to the power of 1 is just itself, so we don't have to write it. That's going to be multiplied by the other reactant, which is I2. And there we go. That is my KEQ for this chemical equation. For this reaction right here, my KEQ would be the concentration of SO3 raised to the power of 2 divided by the concentration of SO2 raised to the power of 2 multiplied by the concentration of O2. So you can see really all we're doing is setting up the products divided by the reactants and raising to the power of their coefficients. But there's an important little side note that we need to make, and I think the best way to understand it is to wipe this clean and take a look at one more example of setting up a KEQ equation. So here I have my chemical equation set up. So I have calcium oxide as a solid reacting with carbon dioxide as a gas in equilibrium with calcium carbonate as a solid. Now, whenever we have a solid or a liquid, they do not, so solids and liquids do not go in KEQ. So what that means for this equation is the KEQ would be our concentration of products, but because it's a solid, we're going to replace it just with the number 1. There is no product that is either aqueous or gas. The only things that go in KEQ are aqueous things or gaseous things. Solids and liquids do not go in. That also means that we would replace CaO on the bottom in the denominator as a solid. We would replace it with a 1, but anything multiplied by 1 is just going to be itself. And CO2 is a gas, so we do include that. And this would be our equilibrium equation. Now, because this is multiplied by 1, you actually don't need to show that. And really just the KEQ is 1 divided by the concentration of CO2. The real key here is anything that's solid or liquid, do not put them into the KEQ. If it is an aqueous or if it is a gas, those two things do go into your KEQ. So really that's all there is to setting up a KEQ equation, and one of the biggest mistakes that you see is people just set up their KEQs wrong when they start doing questions. Remember, it is always products divided by reactants. The other thing is do not forget coefficients. What I would say the biggest mistakes are 2 things. Number 1, people accidentally put reactants at the top. So remember, always put products divided by reactants. Second thing is people forget to balance chemical equations, and then that means they end up missing some of the coefficients. So be sure to balance, include your coefficients, and put products divided by reactants, and this should help you set up your KEQ expressions. In the next video, we're actually going to take a look at what this really means. So what do we do with this number? How do we calculate it? And then what do we learn from it once we know it? So thanks for watching.